So much for a little bit of issue with Facebook. I think I know what it is. I'm quite sure they've ghosted me, but that's not the point. This week, I've got a fantastic interview for you. This week, I'm speaking to the magnificent Professor Ian Pilmer. He is a really, really interesting guy. He's a rockhound. He spoke to me about science, environmentalism as a form of religion, the great scientist Darwin, his relationship with Alfred Wallace, loving rocks and what they teach us. Now, he's been a lifelong rockhound, but he's also done really, really, really well in both the different areas of academia and making a good quid as well. So, look, without further ado, I know you want to hear from him, not me. This is an hour-long interview. It's a little bit so that's a little bit longer, but I assure you, this one is dead set worth it. And make sure that you like, make sure you share, and please comment. I really want to hear what you think about this one.
And I've just come back from Outback. I was out of Broken Hill for a while doing some geological work. And so it's nice and dry here, but we don't get the humidity you doing some geological work.
That's it. And look, it's nice to know you're still on the front line too, proper rockhound. You are, well, just loving that stuff out there.
Well, my very first job was working underground at Broken Hill. That was in 1968. And I haven't been underground in Broken Hill now for 4 days. So I'm getting withdrawal symptoms. Yeah, okay. So I still do a lot of work, a lot of geological work, a lot of work in the bush. I reckon I've got to be the oldest bloke that still goes underground, but who cares?
Well, actually, we will dive into that if that's okay. But first, what I want to do is, obviously, you're famous for your weighing in on the climate change and all that kind of stuff. Straight away, I'm going to give you a chance to repudiate yourself, confess your sins, and throw yourself at the mercy of the scientific consensus and repent.
Well, I'm regarded as controversial because I use facts and I speak the truth. And unlike those who criticise me, those who criticise me are unemployable. They can only get a job in a university, frightening us witless about a possible climate change generations away. They get paid by the average person's taxes to keep them going. I don't have to do that. I don't need to be living off research grants to stay alive. These people are, and if they didn't live off research grants, we wouldn't have a job. So I'm a threat to them. I'm a threat because I tell things that they know, and it's not until they retire that a lot of them will say, "Oh, well, we were peddling rubbish. We knew it was rubbish, but that was my job." So I'm the truth teller amongst a group of scientists. I'm not dependent upon research grants to stay alive. I'm very active in my science, and I'm annoying people because it means that their whole livelihood is threatened. And what I use the past, and I say, well, climate change has been continuous since the beginning of time. We've had 6 great ice ages. 6 out of the 6 started when we had more carbon dioxide in the atmosphere than now. So it's not possible carbon dioxide can drive global warming. They might talk about extinctions. I point out we've had 5 major mass extinctions and at least 23 minor mass extinctions. What's your problem? The number of species on planet Earth is increasing. The amount of extinction is the same. It's just called species turnover. You vacate ecologies and species fill up those ecologies. So all I do is speak what is the truth and what is established science. Established science doesn't use consensus. It's always coming in for surprises. It's always finding new things. And it's really quite exciting to find new things in science. No committee has ever made a great scientific advance. The only committee, in my knowledge, that's ever achieved anything was the Committee of Scholars that spent 30 years putting together translations from the Aramaic, Greek, and Latin into the King James edition of the Bible. That has stood the test of time, but no other committee has ever achieved anything. There's no consensus in science, and I know from my scientific life and my reading that the great scientific discoveries were not made by teams or consensus. They were made by individuals who are out there on the limb, and out there on the limb where they were being pilloried. But these are the people who made the discoveries. So most of the scientists I have worked with in universities and CSIRO, etc., are pretty mediocre. And the only brilliant ones I've met are those who basically are loners. And when I worked on the Australian Research Council with the late Bob Carter from James Cook University, we actually had a small amount of our budget we put aside for the loners. There are loners out there who some of their peers say are nuts and should be locked away, and others say they're absolutely brilliant. Now, if you did the average score of rating these people, which is what is done by the Australian Research Council, these people wouldn't get funded. And so we have to fund individuals who go against the stream. Now, that's not happening any longer in the Australian Research Council. And when I was on the Australian Research Council, we had Minister Dawkins, who said we had a war on cancer. And if you could show that dropping a rock on your foot gave cancer, then you would get funded for research on dropping rocks. Now, if you can show that ingrown toenails are a result of climate change, you will get funded. So science has been totally and absolutely politicised. It's no longer independent. It follows government policy, and you live or die if you deal with science outside the area of government policy, and that's what's happening.
See, that has pretty massive implications, really, for, you know, scientific integrity, because the way I see science is the eyes and ears of the community. Like people like me, I'm obviously, frankly, I don't have the intellectual, and I don't mind admitting this, I don't quite have the intellectual lifting power to like engage in that real deep science. But the other thing is, like, you know, most people are just busy, so we actually do need to rely on experts. But there's this strange relationship between, like, people like me wanting to trust experts, and I've spoken to a couple of other scientists going, you know, you guys have just got to trust the science. Like, you know, we're the experts we're talking about. And it's like, it's not that it's just that I see human beings. Well, I don't think science as a process, because it's a process, look, that can't be compromised. The people doing it can be compromised. And I want to believe, like, I'm Mulder in the X-Files. I want to believe, but I do see a lot of stuff that I just think, nah, especially in the social.
Science is married to evidence, and belief is a word used in religion and politics. And that evidence comes from measurement, it comes from experiments, and it comes from observation. And you have to do this time and time and time and time and time again. And then you can be pretty confident that the phenomenon that you have observed is real. And the next thing you have to do is to try to explain that phenomenon. And that's your scientific theory. Now, evidence is very commonly compromised. We see a lot of it now coming out of Queensland's Jennifer Marahasi, who's showing that the Bureau of Meteorology actually changes the numbers of measurements to get the message they want. We have seen this time and time again with meteorological groups around the world. The former professor of James Cook University, Peter Ridd, he was concerned with quality assurance and quality control. And he argued that most of the science that's done in the climate area has no quality assurance and quality control. In other words, it's very, very shoddy work. And most of the work can't be replicated, and most of the work, the conclusions are based on very, very few data points. Now, that's been well known in the field of medicine. The journal The Lancet, the UK's prestigious medical journal, has shown that more than 50% of all the science that they publish cannot be replicated. Wow. The sample sizes are too small. Their conclusions are preordained, and on it goes. So science has been contaminated by propaganda. Science has been contaminated by governments wanting certain outcomes. Now, we were warned of this in President Eisenhower's departure speech. He warned that the role of governments in science was a retrograde step, and this could lead to science being totally contaminated. There was a time once, and this is when the great scientific discoveries were made around the world, There was a time once when science was independently funded. It wasn't funded by governments. And this is when the huge and great discoveries were made. And probably the greatest scientific theory ever to be put forward is that of the theory of evolution. Now, that was done by Wallace and by Darwin. Darwin got most of the credit, but that was privately funded. When you look at all the science that was done on Captain Cook's voyage, the greatest explorer this world has ever seen, that was done by Joseph Banks. That was privately funded. So the great scientific discoveries have really not been contaminated by government. Government does put a lot of money into science, and it's mainly to keep communities happy, mainly to keep the scientific lobby happy. And also there are military applications of science, and governments are always wanting to have the leading edge on military activities. So I think you've got to view scientists the same way as you'd view lawyers or real estate agents or second-hand car salesmen. They are just as frail. They have their weaknesses. They have their frauds, fools and fads. And just because someone tries to promote a message with a white lab coat, it doesn't mean it's the truth. It doesn't mean it's valid. It doesn't mean the work has been done. And science is blessed with a gobbledygook nomenclature. And that means that you can befuddle anyone and pretend you're an expert. Yeah. A scientific expert, in my view, is someone who can understand the depths of the science and all the weaknesses and all the potential errors in measurement and calculation of what those measurements means, and put it in a language where the taxpayer can understand it. That, to me, is a good scientist, and there are a few of them around.
That's a complete. I mean, that resonates with me, and that's a complete inversion of the narrative that you hear nowadays. Because, of course, all impartial science is funded by an agendaless government, and any science that's completed by a large company, or even with certain qualifications, universities or whatever it is, that's contaminated because, well, that's being funded by this organization. That's going to contaminate the outcome. That's going to compromise the science, and because it's all going to be agenda based. But I think you're quite right.
Well, that's absolute total garbage, because the very best science that I did in my 55 years of scientific work was done mid-career when I was working for a mining company. And I was in charge of research, and I was free to do anything. My job was to sit in a box and come up with ideas. Those ideas, I collected data to substantiate, and I published them. And I had a number of people say, how the hell did they let you get published that? The answer is, I was freer working as a scientist for a mining company than I was working in a university. I was much freer. Now, if that argument is taken to its logical end, then you would have to argue that someone like me, who's now back in the mining industry and employed as a scientist in the mining industry, you would have to argue that because I'm employed by the mining industry, that affects the rotation of the Earth. That affects the orbit of the Earth. That affects the way the sun operates and drives climate. That affects supernova eruptions, which drive climate. That affects the way the continents move, which drive climate. You would have to pursue that argument, and that is clearly ridiculous. And what the arguers are really saying is that I have nothing to counter you. I have no contrary evidence. So what I'm going to do is to damage you and say you are contaminated and you are working for someone equivalent to the tobacco industry scientists. I'm going to contaminate you because I can't answer what you're saying. Yeah. Now, I would put it to them that you have to prove to me that because I work now in the mining industry, that the Milankovitch cycles, the changes of the orbital cycles on roughly 100,000, 40,000, 20,000 years, which put us closer or further from the sun, you would have to prove that that view is the view of the mining industry and in fact is not a demonstrable fact. So that's just madness the way they're arguing, but it is arguing from a position of weakness. And as soon as they are weak, they will attack you. They don't use evidence. Science is married to evidence, and I'm very happy to change my mind if the evidence changes. Now, I have had to do that in my scientific life. I have published a large amount of work on the biggest metal deposit in the world, and this is Broken Hill. And I'm regarded as the expert on the largest metal deposit in the world and how it formed. And I had published many papers showing that this formed at a great water depth in an environment similar to the Red Sea.
Wow.
And I started to mull over what I'd published and kept looking at the rocks and the core. And I thought, well, now I've got this one wrong. I don't think I'm right. And so I went back and I logged about 105 kilometres of core, and had a new think and looked at different settings and have realised that I was absolutely totally wrong. And so I published, criticised my own work, saying, look, Pilmer got this one wrong in the 60s, 70s and 80s and 90s. And now this is the new theory based on evidence, new evidence, and based on a reassessment of the evidence and based on evidence that people have acquired from elsewhere. And I've been able to show that now Broken Hill didn't form in a setting like the Red Sea, but it formed in something like a delta. Now, that is a complete change of thought. The literature is contaminated with my ideas of saying this formed in a very, very deep water setting. And I can say that I was wrong. And I published it. Now, that's what science is about. Science is about acquiring new evidence, new thinking, and reinterpreting. And I've reinterpreted my own work and said that fellow was wrong. Now, that to me is the way science should work. But the climate people, when you attack them with data, they just dig in deeper. They will not say, well, wait a minute, give me a while and I'll go away and think about this and look at some other data. They won't do that. So there's a thread of intellectual dishonesty right through the climate industry. This dishonesty has driven an even more dishonest industry, and those are the wind and solar companies. And that's been driven by governments who really, on one side of government, the super funds have a very large investment in wind and solar, and these super funds are run by unions. So you have to wonder, well, how contaminated is that science?
Yep.
So you've got to go right back to the basics and say, is the concept that human-induced climate change, is that testable or is it wrong? Now, I have posed this question many times to journalists, to politicians and to scientists. And one was to a former chief scientist of Australia, and I sit on a board with him. And I posed the question saying, can you please give me half a dozen scientific papers that show that human emissions drive global warming? Now, when I talk to politicians and the press about this, I get abused. This scientist can't do that. He's a peer, and he obfuscates. But I've now been asking for 2 decades to show me half a dozen scientific papers that beyond doubt show that human emissions of carbon dioxide drive global warming. That hasn't been done. So it's never been shown that human emissions drive global warming. The whole theory underpinning human-induced global warming has never been substantiated. So these are uncomfortable questions I ask. They don't make me very popular. I don't really care. My dog doesn't bite me, and that's as far as I want my popularity to go.
Beer still tastes good, but you're quite right. It does remind me, like in soccer, you got to go for the ball, not the man. And I do see a lot of these arguments, and they're ad hominem, like they're attacking the person rather than the data, which is something I find concerning.
Oh yeah, well, using your analogy, I've red carded the climate science people unless they can answer this fundamental question. Everything that follows on from there is irrelevant. So it's an immediate red card as far as I'm concerned. Now, I'm very happy to change my mind if they can show me convincing evidence. As I did with my own work, I started to have doubt and I was forced to change my mind based on evidence. It wasn't any employer putting pressure on me. It was that I saw evidence contrary to what had published. So I thought, well, whoa, wait a minute, man, you got this one wrong. Now, that's quite normal. People do get things wrong. And there's nothing wrong with saying, folks, I got that one wrong. Nothing wrong with it. Politicians can't do it. And a lot of scientists can't, but if you're married, you have to say it all the time. I got it wrong.
Yeah. Absolutely. And in fact, I'm kind of like a bit of a broken record on that front, Prof. Let me tell you that for no charge. But look, a follow-up question on that. Like, you're a geologist and a very well-respected one. That's beyond argument. But what qualifies you as a geologist when this issue is fundamentally about climate? So, wouldn't a paleoclimatologist?
Everything. No, it's everything, because geology is the ultimate climate scientist. And that's the propaganda that's being fed. Oh, you're not a climate scientist, you're just a geologist. Well, I don't like the use of the word just, because we actually create wealth for this country. And if we didn't live off what geologists have done in this country, we wouldn't have the coal and iron ore that keeps this country alive. But go back in time, look at geology textbooks. And back in the 1700s, geology textbooks had agonizing chapters about whether climate had changed. And this was because French paleontologists had found fossils of tropical critters and plants in the Paris Basin. And they rightfully concluded that that area at one time in the past must have been tropical. Therefore, climate must have changed. It was an inescapable conclusion. And at the same time, people saw those sort of fossils elsewhere in the world. So it became an international view in the 1700s in geology that climate changes. And the origin of the climate change wasn't known. In the 1800s, late 1700s and 1800s, there were huge discussions about dirty big round boulders that were found right across Europe, Scandinavia, the British Isles, the Alps. And these dirty big round boulders were sitting on top of the ground. And the Scandinavians argued that this was a result of a great battle between the trolls who were throwing these boulders at each other. The Christian fundamentalists, and Buckland from England was probably the best known one, argued that this was the proof of the Great Flood, that Noah survived and that water had washed these great boulders across the land. And various Scottish geologists said, no, we think this is a result of debris left behind by retreating ice. Yeah. That ice had moved across the ground, picked up things, and as the ice melted, it had left these boulders that had picked up behind. And the Swiss then went to the toe of their glaciers, which they knew well, and found these boulder beds and boulders from areas where the ice had retreated. So there then became the view that there had been an ice age and that ice had actually covered the continent and had since retreated again. So in Europe, they deduced that there had been once tropical times. In Europe, they deduced once that had been covered by ice. So that gave the geologists in the early 1800s, again, another great view into climate change. And they were, again, tortured with climate change. And associated with that, of course, were discussions about sea level change. Yep. And there was a great sequence of books put out by Charles Lyell. And in 1833, his book, The Principles of Geology, came out. Charles Darwin took that with him on his voyage and got the second volume. I think he picked it up in Rio or somewhere in South America. And in that book, Charles Lyell was arguing that coral atolls in the oceans were as a result of a volcano that had stuck up and then was subsiding, and coral was growing on it and kept growing and growing and growing and growing. So underneath atolls, you should have a thick area of coral, and then you should have a volcano. And that was the same as in the sea level rise. If you have a volcano sink and coral grow, that's no different to sea level rise. And Charles Darwin checked that out. And he checked it out in the Pacific Islands, especially Tuvalu. And he wrote a book in 1842 about coral atolls. And he argued that sea level rise and fall could be measured with atolls. And once you've got an atoll stranded high and dry, like you see in places in Vanuatu, then either the land has risen or the sea level has fallen. And he also argued that coral atolls like Tuvalu were as a result of a relative sea level rise, in other words, a volcano sinking. Now, that idea was checked again, and this is the nature of science. You have an idea and you check it and you check it and you check it and you check it. That was checked again by Professor Sir Edgeworth David from 1896 to 1898, where he drilled a hole on Tuvalu, and this drill hole went down over 1,000 feet in coral. And he was able to get the ages of the coral from the fossils, but he didn't hit the volcano. And that basically substantiated Lyell and Darwin's views. And then in the 1950s, even deeper drill holes were put into coral atolls, getting ready for atomic bomb sites. Yeah. And the coral was drilled, and after thousands of meters, then the volcano was hit, proving the 1833 theory of Charles Lyell was correct. Now, that is basically very important for climate change, because if sea level goes up and down, you can monitor this by looking at coral atolls. Now, more recently, it's been validated again. We've had 40 years of satellite measurements. We've been able to measure now more than 1,100 coral atolls in the Indian Ocean and the Pacific Ocean, and we see that pretty well all the atolls have got bigger. One or two of the atolls have got smaller. This may well be due to the humans using the coral for making cement or road base, or the base for airports or for buildings. But if we have had a sea level rise substantial, then the coral loves it. It keeps growing. So that is one of the arguments the climate change catastrophists use all the time. We're going to have a catastrophic sea level rise, and that catastrophic sea level rise is actually going to be wiping us out. Now, that in geology has been shown to be wrong. We've known that for nearly 200 years. So geology has been dealing with climate for a very, very long period of time. And we look at various rock sequences, such as red bed sequences, and these are where you get red desert sandstones. And we see some great periods of time in the past where we had the planet having great deserts on it. And adjacent to the deserts were salt lakes, and sometimes the waterways were a bit like the present-day Red Sea. So we have been dealing with climate and climate change for over 200 years. Yeah. And it's only just recently we've had groups of mathematicians who are unable to get a job, and so they get into modelling climates and then get a job in a climate institute or a university, and they call themselves climate scientists. These people are unemployed mathematicians. They are making projections about something that's going to happen in hundreds of years' time. Whereas when we look back in the past in geology, we can see that we've been concerned with climate change for hundreds of years, and we can see over billions of years climate change has occurred. So that argument that, oh, you're only a geologist, not a climate scientist, is basically used to say, I'm not going to argue evidence with you. I'm not going to deal with evidence at all. I'm just going to denigrate you and move on and keep frightening people and getting paid while I'm eminently unemployable.
Yeah, it's going for the man, not the ball again. But it's really funny how there's a link to Darwin in this, and you mentioned Darwin and Wallace at the beginning. Now, if you have the inclination and the knowledge, I'd really like to discuss a little bit about Darwin and Wallace. I think that partnership / competition between those two men really is still being played out today. And you know, because Darwin's understanding of evolution took him away from Christianity, whereas Wallace's took him closer to God. And I know you also had some really big run-ins with literalist fundamentalists in the 90s. I actually remember that. So I'd really kind of like to discuss those relationships, should you have the time and inclination.
Well, Darwin is buried in that great Christian institute called Westminster Abbey.
Yep.
That's where he's buried. He had a really very faithful, almost fundamentalist wife. And he was more interested in the science and didn't really care about upsetting religion. And we are facing similar things now. Once, and it will happen, once fossil life or modern life is found on Mars, then that will be another great advance in science. Will also rattle religion, because the implication is that God created life on Earth. Yet if we find life elsewhere, that is a real rattle against religion. And that'll happen probably in your lifetime, but we've certainly got faint evidence now that there was life once on Mars. In the 1990s, we had a rise of creationism in Australia, and the creationists argue that the planet is 6,000 years old and that all the sedimentary rocks formed 4,000 years ago, and the surface of the planet was shaped by a great flood. Now, I don't have a problem with people having ideas which are crazy. However, the creationists wanted to teach this in the school science courses as part of established science. And therefore, I felt, and I was then the professor of geology at the University of Newcastle, I felt that this was an attack on the school system, an attack on science, and so I became quite vocal. And later, when I was at the University of Melbourne, got involved in some litigation on this matter, and I was quite happy to pursue this litigation because there is no evidence that the planet is 6,000 years old. There's only evidence to the contrary. And even before we had the radioactive dating techniques, we could deduce, and we did that in the 1780s, we could deduce the planet was extraordinarily old, not 6,000 years old. The second thing is that there is no evidence of a global flood. There's so much evidence saying that that's absolute garbage, that it's wrong. However, one particular gentleman claimed that he'd found Noah's Ark, and that was at a site near Mount Ararat in Turkey. I've been to that site a couple of times, and yes, there was certainly a boat-shaped like rock outcrop there, which for hundreds of years the wily Turks have said, well, this is the fossilized Noah's Ark, and pay up and we'll take you and give you a look at it. Now, I have no doubt that there was a great flood. It wasn't global covering, but we have evidence from Sumerian myths and from the Noah myth that there was a great flood, and that was a great flood in the known world. That myth has been substantiated by the chap called Bob Ballard, who, with his submersible, found the Titanic. But to fund that mission, he had other ventures, and he went to the Black Sea and found on the floor of the Black Sea old villages with foundations, wooden foundations for buildings, pens and evidence, pens for stock and evidence that soil had been covered by turbulent marine sediment that had been washed in. And Ballard was able to show that 7,400 years ago, we had a movement along the North Anatolian Fault. Sea level had risen quite substantially because of the melting from the last glaciation, and that melting started 14,700 years ago, and we've had a total of about 130 metres sea level rise. So we had 7,400 years ago maybe a sea level that was 100 metres higher than the floor of the Black Sea. And we had the move along the North Anatolian Fault. This water from the Marmara Sea cut along this fault, which is why the Bosphorus is straight, and poured into the Black Sea basin. And there's all sorts of myths and linguistic evidence to show that the population there got flooded out. They dispersed and took with them their language, their matriarchal society, their metallurgy, and that became the Noah myth. And that also then had the religious moral overtones put in it, that the sinners died and the good guys survived. Now, Noah was probably smart enough to say, well, blimey, I want to put a few goats and sheep on a little raft and my family, and we'll ride this one out. Not every animal in the world, but these myths tend to change over time. So I have absolutely no doubt that recorded in literature and substantiated by science, there was a great flood of the known world. But geology has shown that. But geology has also shown that there was no global flood. So my battles with the fundamentalist creationists was to avoid having what is clearly religious, anti-scientific dogma taught in the schools. My battle with the climate catastrophists is no different. They have this religion called climate change, which is a dogma which they want to promote in schools, and they've very successfully done that and frightened generations of kids. So my battling with anti-scientific ideas has been quite consistent, be it creationists or be it climate catastrophists.
Absolutely. And it did us. It's like you're channeling me. In fact, that's where I was leading with that line of questioning. I was going to ask directly as to whether or not you think what's happening now is comparable, and quite clearly, the answer to that question is yes. So you've got a lot of people.
Yes, the climate catastrophists have their Bible. It's called the IPCC reports. The latest one they would not have read. It was nearly 4,000 pages long. They wouldn't have read it. They wouldn't have understood it. They wouldn't have understood the science, but it has a summary for policymakers and politicians, which is catastrophists and screeching with doom and gloom, a bit like the Book of Revelations. They might have read that, but all they pick up is stuff that comes through from the media. They, like Christianity, have their sins, and you must pay indulgences, which we are paying with our high electricity prices, and the spearing of our countryside with these wind turbines and destruction of prime agricultural land with solar panels. We are paying our indulgences. We have our high priests like Al Gore and Tim Flannery. These are people who you cannot question at all. And we have our hell and damnation, and people like me suffer from that. So it is the new religion, and I had many discussions with the late Cardinal Pell on this matter. I'm not religious, I'm not Catholic, but we had this in common, and he agreed with me, or I agreed with him, that this is a new religion, and this is a new fundamentalist religion. It's got all the hallmarks of a fundamentalist religion where you cannot question.
Absolutely, yeah, and so I couldn't agree more. All I want to do is endorse that, really. But let's talk about Wallace. He's kind of like, he really never got the love and respect that he deserves scientifically. I mean, he's just got a line named after him between a couple of islands in Indonesia. I mean, the guy kicked backside. I'm a bit of a Wallace man. I think he's kind of cool.
Well, Wallace's work was done on observation of flora and fauna in Indonesia, or what we now call Indonesia, and Darwin was very much aware of this, and Darwin was a bit of a slow coach, and his voyage of the Beagle was a very slow voyage. He made a lot of observations. The principal ones we know about are on the Galapagos Islands, but he made a lot of observations and was one of these gonna-do blokes. He was going to write it up. Never quite got around to it until Wallace had a paper written on what he had observed and was starting to get to the view of interpreting evolution. And Darwin thought, well, he'd better hurry up. And Darwin then published in his in the same journal, in the same issue as Wallace, he published a paper. And Darwin was a much better publicist. Wallace was still out in the bush. Darwin was in the social set of the UK, and Darwin was able to promote himself, and then put out his 1859 book on the origin of species. And Darwin was very, very significantly able to capitalise on the theory of evolution and get the credit for it. Whereas I think it's like with a lot of great scientific ideas, quite often people in different cultures, basically at the same time, come to the same conclusion, because you have a body of evidence, you need to cogitate about it, and you come to the logical conclusion. And Wallace came to a logical conclusion about evolution, but didn't promote it. Darwin came to the logical conclusion from a different set of data, and promoted it and got the credit. So that's the unfortunate nature of science. Now, we see that all through science. We see, I mentioned earlier about Charles Lyell's book of 1833, and he was pondering on the geology of some continents and pondering on the shape of continents. He very, very nearly deduced that there was a process called continental drift. Now that, again, that process was revived by a German called Alfred Wegener, and he put out a book in 1913 and Wegener was a meteorologist, but he looked at rocks. Wegener looked at the direction which glaciers had moved, which you can deduce from scratching on rocks. Wegener had worked out that from the geology that the continents must have once been joined. And he suggested the continents were drifted apart, and he proposed a mechanism of a centripetal force to do this. He got absolutely pilloried by the physicists in Cambridge, and he got pilloried simply because the physics didn't work, but more likely because he was German, and that was all the criticism came in the First World War. So Wegener's ideas died, and they were revived again by returned servicemen who'd been working in the Second World War. They'd been towing magnetometers behind ships to try to find magnetic material beneath them, in other words, a submarine. And they found that when they plotted up the magnetic patterns of the tow line, that the seafloor had a striped magnetic pattern. So they tucked that away in the brain. And then after they got a university education after the war and developed their scientific careers in the 1960s, they then realized that the ocean floor was expanding. And as it was moving apart, at times it became reverse magnetized and then back to normal magnetization and reverse magnetized, which gave the stripes on the seafloor. And that's how the theory of continental drift arose. But the theory started, the thinking about it started 130 years before that. So great theories just don't happen with a eureka moment. They happen with people experimenting with ideas, getting smashed down, getting new data, different data, and eventually coming to an idea. Now, Darwin's theory of evolution is probably the greatest scientific theory we've ever had. It's been tested and tested and tested and tested. Yes, there are slight modifications here and there, but that is the greatest scientific idea ever on planet Earth. Wallace should have got the credit, but that's the way science works. And there are many scientists out there who are chasing fame by promoting themselves widely. A good example in the climate industry would be, say, Tim Flannery in this country, a number of well-known names in the US, Michael Mann, for example, and the way he promoted his science was basically fraudulent. But he is known as a great climate scientist by those who want to follow that view. So don't think the science is any special. The scientists have egos, the same as everyone else. They conduct fraud, the same as anyone else. They have their fads and fashions. And so science basically progresses one funeral at a time.
It's a really good way of talking about it. But I noticed that somehow you brought it back to rocks, that conversation there, talking about Liddell and this guy looking at rocks. So let's talk about geology. What got you into it, and where has geology taken you, and what do you love about it? And I got to throw up my hands here, Prof. I'm a bit of a rockhound too. Okay, so this is a safe space.
I was a young kid in Sydney. We didn't have social media. We didn't have television. We actually went outside and played. We played with friends. We played with imaginary friends. We went out in the bush. You had to be home by dark. That was all. And I found some fossils when I was out in the bush. Wow. And I was quite interested in these. And so I took them into the Australian Museum in Sydney. And this must have been when I was about 8 years old. And rather brazenly asked to see the curator. He came and saw me. He had a look at these fossils, and he was very gentle and very kind and explained what they meant and what they were and how old they were. I now realise that this was absolute rubbish that I had. But yes, they were fossils, but they were nothing very special. But he put time into me, and he basically stimulated me to be more interested. And then at school, high school, I was making crystal sets and making radios. Yeah. And I once asked my chemistry teacher, well, how do you get copper? How do you make copper? And he said, oh, I'm too busy, but come back tomorrow, I'll tell you then. I now realise he didn't know, but he'd gone back and looked it up. And he told me that you had this copper mineral, and you'd mine it, you'd crush it, you'd grind it, and you'd be able to float this heavy mineral by attaching bubbles to it. And then you could smelt it, and you'd then create acid, and you'd create copper, and then you'd have to refine the copper, and then you could draw that copper out into wire, and that wire that you're using was covered in an insulator, but that's how you got it. And I thought, wow, this is something else. So I got quite interested in minerals, and that's why when I went to university, we had a fourth subject to pick. We had to do mathematics, physics, and chemistry. Later, we had to do English literature and a language and other subjects, but I picked the fourth subject as geology. Biology was the one where all the young girls were, but and psychology. Well, if you wanted a girlfriend who's a bit nuts, you did psychology, but I did geology. And there were a group of about 30 of us who started in first year. And one of the blokes who I started in the first year with is my closest personal friend. He lives up near you at Chillago, and he's been a friend since February 1964. We had a reunion of all of those that started and finished geology. We had that only a week or two ago in Sydney. Now, these blokes are, some of them have carked it, some of them have gone different directions. Most are bald and fat and drink far too much. So interesting to see. Their basic personalities haven't changed very much, which was also very refreshing. So then I started at university, and I had a professor who could see that I was absolutely passionate about geology, and he took a great interest in me and really got me stimulated with it. And he was a great landscape artist, and so he could draw with coloured chalk on the blackboard three-dimensional geological models in different colours, which was just wonderful to see the evolution of this while he was doing it on the blackboard. And it was only the other day that I was talking to one of my fellow students. I didn't know her then, but she was in that class as an arts student, and arts students had to do geology or a science subject, and science students had to do an arts subject. Now, that was John Howard's wife, Jeanette Howard. She was in that class with me doing geology, and I didn't know her then, but we had a good chat about that, and had a good chat about my professor, Laurie Lawrence, who really stimulated me with geology. And while I was a student, then I had my former school teacher come to me and say, look, in New South Wales, they've changed the syllabus. We've now got this Wyndham scheme, which was an absolute disaster. And we actually have to teach some geology. I know nothing about it. Can you write some chapters in a textbook that your old chemistry teacher and your old physics teacher are putting together for school kids? So I did, and I was greatly honoured. Here I was as a second or third year university student, writing a textbook chapter with my former school teachers who really inspired me with physics and chemistry. And that was a real boost. And then my first research project I had under Professor Laurie Lawrence was working underground at Broken Hill. I was only a mile underground, a mile vertically, looking at this ore body, which is chemically just weird. That ore body has some 400-500 minerals found from it, some of which are only found at Broken Hill, some of which were first found at Broken Hill, like a mineral that scientists found at Broken Hill and named it after me, which is a huge honour. And so I was then in Broken Hill, and I lived in Broken Hill for a period of time, and then I came back and I did a PhD up your way at Wolfram Camp, north of Mareeba. I did a PhD on that mine, which was then operating. Again, that was fascinating for me as a mineral deposit. And again, looking at the sort of gases that are involved in forming these mineral deposits, things like carbon dioxide. So we geologists have been dealing with degassing of the earth for a long period of time. And then after that, I went back and lived in Broken Hill. And I became then, and that was in the 70s, quite an expert on Broken Hill. And I had the International Mineralogical Association ask me to run a field trip out in the Donga of outback South Australia and outback New South Wales for all the museums around the world collecting museum type specimens. Now, I knew all these spots because I got to know all the prospectors and miners at Broken Hill, got to know all the little shows, because I used to teach a course in mineralogy, just out of interest for these fellows. And they were good people. Anyway, that was in 1976. And on that field trip, like all field trips, you sit around at campfire at night and have a few drinks. And there was a Canadian bloke who asked me, he said, "Oh, Ian, what got you interested in geology? What was the real stimulus for getting you interested in geology?" And I said, "That bloke over there." And that was Ollie Chalmers, who was the curator of minerals at the Australian Museum in Sydney, who was the one that identified these fossils for me and really got me interested. Now, this bloke then would have been in his 70s, and he was absolutely blown away with sheer joy that he had stimulated some snotty-nosed 8-year-old kid who then had achieved far more than he did in the world of mineralogy, and it really made him. And then after that, when I was a professor at University of Newcastle, I used to have Ollie Chalmers come up by train from Sydney to Newcastle, and he'd come up to have a few red wines. You know, we'd have to tuck him into bed. We'd go all afternoon. And I also had Professor Laurie Lawrence, my university professor. He was very proud that one of his students had become a professor at a very young age. I was the youngest member of staff when I became a professor at Newcastle. And he used to come up and also drink red wine, and we also had to tuck him into bed. So I was extremely lucky that I had teachers and curators and professors who took a personal interest in me, who really stimulated me. They could see I had an interest. They could perhaps see I might have had, you know, more than the average intellect. And they just really took me under their arm. And I have always used that. I've always used that to try to help students and help young people. I'm mentoring 9 people at present, or helping 9 people, some of whom I mentor, some of whom I help financially, because these people did it to me. So you have to give it back. Wow. And you learn from these things. And one time, I hope this lady's not alive any longer, but one time when I was to go for a 3rd-year university examination in paleontology at university, I went to visit my girlfriend before I went for this exam. And one thing led to another. And I got to the bloody exam room late, and I was locked out. And those are the days, if you failed 1 unit, you had to repeat the whole year of every subject, not just that unit. And so I went to Professor Lawrence and said, "Look, I got waylaid by my girlfriend. I'm an hour late for the exam. I'm prepared to cop it on the chin." He said, "Right." So he sat me down at his desk and gave me the exam paper, which I had an hour less to do it, but I got through it and passed it, and so I didn't lose a whole year. Anyway, wind the clock and go to about 1997. That was 1966. Go to 1997 at the University of Melbourne. I was a professor and head there, and I had a student waltzing all flustered and carrying on, saying she'd been locked out of the exam and her tram was late. And so I told her the story of Laurie Lawrence, and I said, "Was your tram really late?" She said, "No." She said, "I visited my boyfriend." And I said, "Right, you sit here. Here is the exam. You've lost it. Off you go." And she passed. And so I've often thought, well, it's good to remember these things and be a beneficiary of someone's kindness, because what happens, kindness and good judgment, what happens is you pass this on. And that's what I did. I can't remember this girl's name. I don't know who she was, but she got through. Her tram wasn't late. She had a good morning session with a boyfriend, and passed her exam. So, you know, I've been incredibly lucky in life, where I've had these wonderful situations, but I've also been able to capitalise on what I know and what's happened to me, and be able to assess a person and see whether they're worthwhile going and batting for. So these have been...
Well, boss, it's like this.
Well, I've never had it since, but it only happened to be once in life, to myself personally, and then when I was the boss. So, yeah, so this is one of the reasons I spend a lot of my time giving back. I'm patron of Lifeline at Broken Hill. That town's given me its my career. I was once staggering down the main street of Broken Hill after a very lengthy and liquid lunch, and I ran into the local Uniting Church minister. He was running Lifeline. He was a drinking friend of mine. We used to spend Sunday afternoon out at Silverton drinking with a few other reprobates, including the Anglican priest, etc. And he looked at me in my sorry state. He said, "Pilmer, this town's been the making of your career. I want your book royalties." And I said, "Yes." Now, since then, Lifeline have made quite a large amount of money for my book royalties and various guest lectures that I've given around the place. And I think, well, I don't need the money. Lifeline does. When it's in Broken Hill, I know what's happening to it. I can see how many administrators they've got and how they're spending it. I've never needed Lifeline, but I know a lot of people do. This town certainly did make my career. It's time to give it back. So for quite a long time, I've been giving back, mentoring, and that's all the result of what happened to me.
Yeah.
If I was just a grade A student, which I wasn't, I had to work hard all the time, then I would have just breezed through, and no one would have noticed. But it's been a bit of a grind, and you see other people having a grind, and you help them.
Yeah. So would you recommend geology as a career? I mean, it sounds, like I said, it's hard yakka, but it sounds pretty cool.
I've been to about 90 countries in the world doing geology. Someone else has paid for those trips. Oh. I'm up the front of the plane. I go to places that tourists pay tens of thousands to go there. If you want to see the world, do geology. If you want to meet really unusual cultures, do geology. I've worked in places, I've just written stories, quite a lot of stories about it. I had one recently published in The Spectator, just I think a week and a half ago, about a young kid I met in Turkey. I called my Alashahir mate, and he was a kid who was my guide, but he suffered extreme mercury poisoning. And it's a very tragic story. I've written stories about going to a lone grave site right out in the outback and asked the questions, well, who was this person? What was his life like? Why are there children's graves around them? How did they, did they get wiped out by the drought of 1890 and the depression of 1890? I've written stories about streets that I've seen in Africa, in Rwanda, after a revolution, where there are just bodies lying there. If you want to see the world and see different cultures and learn different languages, do geology. But you can't be a princess. You can't be worried about getting dirty. You can't be worried about being claustrophobic and going underground. You can't be worried about flying in aeroplanes. You can't be worried about climbing steep hills. And so in my career, I've had the choice as to whether I want to sit at a desk, or whether I want to go bush, or whether I want to go underground, or whether I want to travel. It's also intellectually extraordinarily stimulating in that the history and philosophy of science is basically wrapped around geology. And I gave a little bit of that when I was talking about Darwin and Wallace and Lyell, etc. And so if you want to get intellectually fulfilled with big ideas, with deep time, then that is the stimulating part of it. But geologists, most of the employment is in the mining and exploration industry, and that unfortunately has cycles. So there are periods of time when you make a lot of money. And there are periods of time when you might be struggling for work. It is a cyclical industry, but I know many geologists who are very, very wealthy, and I'm talking hundreds of millions. So it's a very exciting career, and you couldn't really be entering it at a better time, because so few people are doing geology now, because the greenies are saying, oh, this is raping and pillaging the country. Well, I'm sorry, our country depends upon iron ore and coal, and for that we need geologists. People are saying, oh, these people are pollutants. Well, I'm sorry, what are you going to do? We live in a planet where we use steel, fertilizer, cement and plastics. Pollution is up to you. It's not up to those providing the commodities. So there couldn't be a better time to go into geology. There are so few people going into geology, into mining engineering and minerals processing. And it is a career that enables you to be an entrepreneur. It enables you to be an employee. It enables you to be a world traveller. Many of the geologists I know have been in really interesting parts of the world where you can't get to now. So it's a very, very exciting career. And I've often thought, if I had my time again, what would I do? And I'd probably do something like geology again, or maybe something very similar. But I couldn't think of anything worse than being a medical practitioner in four white walls every 10 minutes, having someone moan and groan at you, or being a dentist trying to conduct conversation with you with someone with their gob open and you can't have a conversation, or being a lawyer basically ripping people off because they've got a problem. I mean, there's nothing fulfilling about that. Or being an accountant, counting someone else's money. All of those are people in a little white room. And I had my accountant and my lawyer and my medico, they ask me, well, what have you been doing? They get absolutely excited by the sort of life I live.
Yeah.
I'm 77 years old. Now, a couple of days ago, I was underground. I was only a kilometre underground. It was pretty hot and nice and humid and wet. Now, how many people my age go underground? And I'm fit enough to do it. I don't have a problem with it. And it's just fabulous having this three-dimensional view of the world. And so I've been incredibly blessed, but it just hasn't happened. I've had to go gunning for everything. I've never been given anything on a plate. I've had to be an opportunist and had to go fighting all the time.
Part of the look, quite clearly, part of that is, though, you don't just have a scientific mind, you've got an imagination as well. I think it's rare to get that the really methodological, just the facts, going through that mixed with an imagination.
Well, yes, there are geologists and geologists. The exploration geologists tend to be creative and have an imagination and tread where no one else has trodden and test new ideas. And you test ideas with drill holes. You test ideas by compiling a huge amount of data before you spend a large amount of money on a drill hole. Other people validate data and might do less testing work, such as a mine geologist. Other geologists involved in research are chasing new territory all the time. And there's always the big questions. And the big questions are the origin of the universe, the origin of the planet, the origin of life, the evolution of life, the extinction of life, the great climate changes. As I mentioned, we've had 6 great ice ages. Now, 6 out of those 6 ice ages started when we had more carbon dioxide in the atmosphere. And we've had at least 2 ice ages where ice was kilometres thick at sea level at the equator. And there are huge scientific questions. How did that happen? Well, the answer's simple. We don't know. How did the ice melt and go away? We don't know. Now, that is the excitement. And there are so many fields where you're not at the leading edge of exciting new knowledge. I mean, I couldn't think of anything worse than being a lawyer, where you deal with precedent. You're not dealing with creating something new. And one of the great things about geology is you can create new wealth. You can create new ideas. You can create new experiences. And some people, and this is personality dependent, are more likely to take fewer risks. And so they might sit with an employer and work at a mine. Others in exploration take a lot of risks. And it's a throw of the dice. They may well be well rewarded. They may well fail. But who cares? It's excitement.
Well, that's pretty inspirational. And on that, I think we'll wrap it up. I haven't got any more questions for you, unless there's something, just a general comment you'd like to make to the good listeners of Northern Vibe. So it was a fantastic interview. I hope you enjoyed it as much as I did. Ian is a really, really interesting guy. And I got to be honest, after listening to that bit at the end, I kind of, maybe I should have done geology. I've got some fantastic interviews coming up. Do make sure you comment, make sure you like. Thanks very much to the people who have already done so. But please make sure you share and tune in next week to Northern